If you finish before the time is up, you may begin taking these notes, because it was obvious to me that you guys did not memorize these as I asked you to at the beginning of the year. Okay? All right, so these are just the background, because we need to recognize if I have a perfect square so that I can take the square root. And sometimes you're going to get a number that you can't take the square root of because it's not a perfect square. However, it may have a factor that's a perfect square. So we're going to see all sorts of problems today. All right, so what we're going to be doing is these variable expressions are going to be things that contain variables, monomials that have variables and coefficients. And so we had talked a little bit before when we were solving equations using factoring. If there wasn't that linear term, we would have a squared term and a constant, and we could take the square root of that variable. And I said if you take the square root of a variable, we don't know whether it's a positive number or a negative number, because that product could be the result of multiplying a positive times a positive or a negative times a negative. So when we're doing equations, we have to allow for both. However, when we're doing simplifying radicals, we're going to assume all our variables in these expressions represent non-negative real numbers. So we're only going to go with the positive version. So this is what we talked about last week. If we have the square root of x squared, I said last week in the equation you would have to write plus or minus over here, because I don't know what value we're talking about. According to what we're going to do with these expressions, notice the difference. What I was talking about last week was equations. This is expressions. When we're talking about expressions, and we've got an x squared, and we want to take the square root, we're just going to look for the positive version of that root. Okay, so we're just going to focus in on that. The other thing I have to show you is what the book does. The book says if I have this number and I take the square root, because I don't know whether it's positive or negative, but we're going to want the answer to be positive, the book writes the answer this way. So when you're grading your homework and you see absolute values around your variables, know that it means the same thing as this, and you don't need those absolute value signs. Okay? Chloe?
Should we put the little plus sign?
No, you don't need a plus sign. That's just emphasizing that it's only the positive version is what we're looking for. So when you see in our notes, when we go through examples, you're not going to see anything that looks like absolute value. You're going to see everything that looks like the middle one without the plus sign in front. Okay? So we had talked about before when we were taking square roots for our factoring, what did we do to the exponent when we took a square root? When you take the square root of a variable, what did we do? What did we say that you would do to the exponent? Justin? You would cut it in half. Now, I'm going to put a little proviso. This has to be true. So when you take the square root of a variable that has an even exponent, because you can't cut in half an odd number, cut the exponent in half. And let's talk again about why that's true. Where did that come from? All right, we have a square root, and it's of a variable x. So there's two numbers, kind of like hidden Mickeys, that are there, but you don't see them. What root is square root? What number goes with square root? Anybody? 2. So in the crook is a 2. Now, this is the only radical sign that doesn't need a number is when it's a square root. Every other root, cube root, fourth root, 25th root, doesn't matter. You had one, what was it, the 48th root, I think, on the Super Bowl that you had to use. That number has to be put in the crook. But if it's square root, I don't put it in there. So you're not going to see that too. Just like, what's the exponent on this x? 1. You don't see that either because I have 1x. I don't need to tell myself I have 1x. I already know I have 1x. So how we can rewrite that problem without the radical sign is we're going to create a fraction out of the two values, the root value and the exponent value. So it looks like this. Whatever exponent is on our variable underneath the radical sign over the root number. Ugh, that's terrible too, sorry. I'm trying to make them look better. I'm just making them look worse. Okay? So the bottom line is this. The square root of something is the same as, let's put a variable here. Let's just put x to the half power. And when I cut an exponent in half, what I'm doing is multiplying it by 1/2. When I'm raising a power to a power, I multiply the exponent, so I'm going to be multiplying by 1/2. So that's the same thing that we're going to be doing. Now, we will talk in the notes what happens if that exponent is not even. How do we deal with that? Okay, so let's go ahead. We're going to go over a couple of examples. We'll start off simply, but again, we're going to show you multiple steps so that you understand how I got what I got in the process so that you can replicate it when you're working on your homework. So let's start off with the square root of 16x to the 4th. So in monomials, we may have coefficients, we may have more than one variable, okay? But what we are not going to have and be able to take the square root of is if I have multiple terms being added or subtracted. I won't be able to do that unless there's some special conditions being met. So what I'm going to do is split this into each of the parts. So I'm going to see if I can take the square root of 16 and see if I can take the square root of 4. Well, 16's on our chart. What is the square root of 16? What times itself gives me 16? Right, the answer is 4. So over here, just to prove out how this works, I have x to the 4th, and I want to raise it to the half power. So power times a power says 4 times a half equals what? 2. So that's how I get my answer of 4x squared. Yes?
Do the 16 squared x squared?
No, again, what I already prefaced what we're doing here by showing you how we get our answer is step by step. And I want you to understand that. All right, square root of 121, because there's going to be some times when you're going to realize, ooh, I am going to need to do this because I have some issues that aren't working out, okay? So I have the square root of 121, x to the 6th, y to the 8th. So again, I'm going to split this monomial into each of its components and take the square root of the 121, square root of x to the 6th, and square root of y to the 8th. What's the square root of 121? 11. Now when it comes to these other guys, I have x to the 6th that I want to raise to the half power. That's what the square root means. And I have y to the 8th, and I want to raise it to the half power. Oh, come on. I'm having trouble writing today. Again. Let's try this one more time. So half of 6 is 3, and half of 8 is 4. Now, I do need to mention something that somebody brought up in period 1. They said, I don't understand why you don't keep taking the square root of 4x squared. 4 is perfect square, x squared is perfect squared. And there's a simple answer to it. Is there a radical anymore? No, it's gone. There's a whole point. The reason why it's gone is because I've taken the square root. Once I take the square root, the radical's gone. Okay? The only time a radical remains in an answer is if I couldn't take the square root. So, here goes the next one. And this one is the first one with a little bit of a twist. Square root of 24, x squared y. So I've got the square root of 24 times the square root of x squared times the square root of y. All right, 24, perfect square? Ooh, and so this is where we run into a problem. What I need to do is think of factors of 24 where I have at least one perfect square. So think of your perfect square list, and what do you know can go into 24? What can go in? 4. Now the first number you should tell me is 4 because that's a perfect square. 6 is not. So what I'm going to do is take the square roots of each of those. With the x squared, I'm going to raise it to the half power. Can I take the square root of y? I can't, because I mean I could write it as y to the 1/2 power, But I can't leave that in an answer. So what I'm going to do is take the square roots of what I can take the square root of, which is I can take the square root of 4, and I can take the square root of x squared. That's going to give me 2x. And then the other two that I can't take the square root of, the 6 and the y, I'm going to leave them under the radical. And that's my answer. Some comes out, some does not. All right. What if, oh, look at this. I got a coefficient this time. I've got negative 5 times radical 80 x cubed y to the 5th. Okay. So I've got negative 5 times the square root of 80 times the square root of x cubed times the square root of y to the 5th. All right, so let's tackle that 80. What's a perfect square factor that can go into 80?
4 and 20.
Okay, so we've got a 4 times a 20. Oh, the problem is 20's got a perfect square in it. What is it? 4 and a 5. So note that square root of 20 no longer exists. It's now square root of 4 and square root of 5. Okay, so square root of 4, that, dear folks, is square root of 16. 16 is the greatest perfect square factor of 80. Okay, a lot of us look at the little guys. That's a great way to start, but sometimes you need to look bigger. Now, lurking inside of x cubed is a perfect square. If I just take out one of the x's, it leaves me the greatest even exponent that's left. Okay? Same thing, if I take away one of the y's, it leaves me with the greatest perfect square that I possibly can do. All right, so here's what I'm going to do. I still have negative 5 in my answer. Now I'm going to take all the perfect squares and take their square roots. What's the square root of 4?
2.
Square root of 4.
2.
We had another one, right? Square root of x squared. X. Square root of y to the 4th. Y squared. Remember, 4 cut in half is 2. That left behind a 5, an x, and a y. So that's what's going to go underneath my radical is the 5, the x, and the y. And then my job is to simplify out in front. So negative 5 times 2 is, and negative 10 times 2 is negative 20 x y squared times radical 5xy. So when I'm trying to take the square root of an exponent that's odd, I'm going to take one out by itself, and the rest is going to be the biggest even amount that I have for that particular factor. Okay. Oh, I still have another minute. How about this guy? Square root of 288, a to the 10th, c to the 12th. So that's going to break into the square root of 288. Is that a perfect square?
No.
No, it's not. Square root of a to the 10th times square root of c to the 12th. Okay, what could I do about 288? How could I explore this? Does it have a perfect square factor inside of it? Yeah, what does it have? 4 goes in, and it goes in 72 times. 72? 9 times 8. Square root of 9. Oh, square 8. What does it have in it?
4.
A 4 and a 2. Oh my goodness. So here we have a square root of 4, a square root of 9, a square root of 4. By the way, 144. Square root of that is 12. I know, crazy, huh? When we don't see it. So we have a 2 times a 3 times a 2. What's the square root of a to the 10th? A to the 5th. And how about c to the 12th? What I wasn't able to take the square root of was a 2, and that was it. So 2 times 3 is 6. 6 times 2 is 12. So my answer is 12, a to the 5th, c to the 6th, radical 2. All right? Okay. How about if we have a fraction under a radical? How is that going to do? Be any different? And the answer is not much. I just got to treat everybody the same. So we're going to break this down into the square root of 9 times the square root of n to the 8th all over the square root of 400 times the square root of p to the 4th. And every single one of these is a perfect square. Square root of 9 is 3. Square root of n to the 8th is cut the exponent in half, n to the 4th. Square root of 400 is 20. Square root of p to the 4th is p squared. And there you go. Last is the trickiest one. Remember I said earlier that you can't take the square root of terms if there's addition and subtraction. So is there some way to turn this trinomial into something that is a factor that's squared? So what you should look for is it a trinomial square? So if you don't recognize it, if you try to factor it playing the game, if you get the same factor, then that tells you it is a trinomial square. So to factor into the quantity, x minus 6, quantity squared, and the square root of something squared is that item. So the answer is the binomial x minus 6.